Hello all, welcome to the episode 18th in hexadecimal of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on the website debugging.tv. And so excuse me for my harsh voice also today. The topic of this session is stack frame navigation with and without source code, as were requested by some participants of recent accelerated Windows memory dump analysis training. So I promised them some free session to show this stack frame navigation that was missing from training agenda. In order to have an example with function parameters and local variables, I borrowed an old example used 5 years ago for comparison of DDB and WinDbg. That example was for live debugging with breakpoints. I modified it for crash dump analysis by inserting null point access violation and recompile under Windows Visual Studio 2012 64-bit version, 64-bit compiler. I use the latest WinDbg from Windows SDK for Windows 8. And I also enabled local dumps, register key on Windows 7. So this is source code of this test program I created. Hello World was replaced with Hello Crash, and some functions call each other, like main function calls func1 calls func2, and some parameters are passed, and also there are local variables. It's just to test various WinDbg commands. And at the end we have null pointer access violation after Hello Crash. So when we run this application, crash dump is generated. So I already created that crash dump, so what I do, I open WinDbg and load this crash dump. So what I do, I open a log file using .logopen command. And I fix symbols to point to Microsoft Symbol Server. And do reload. So when we type K command to see Stacktrace, so we get that frame navigation module, but no functions and offsets. So we need symbol files. Actually, symbol files are in the same folder. So Actually, symbol files are missing. So there is a command lmi, ban lmi, that gives additional information about module. So frame, we put that module frame navigation. And you see that it shows where WinDbg is expected to find PDB file. But in fact, PDB file was removed from that location in order to test without PDB files, without symbol files, and put into another location. So now we fix that and use sympath command and supply the folder where PDB file is located. It is in this folder, but in subfolder test. Sorry, mistake. Put comma instead of dot. So let's do reload and try to get Stacktrace. So now we get good Stacktrace with all these functions. So we see function main called function 1, that called function 2, function 3, function 4, and finally we get exception. So exception processing code. Also see the references for source code. Sometimes these references can be unknown, so if we use TL capitalized, we get the same Stacktrace without source code. So now I'll show you how to navigate through these frames. So each line is a frame with its own local variables and parameters. So we can use key and command, so they are numbered now. So what we are interested in is, for example, frame C. This is function 4. So let's use this command frame C. So we are now in this frame. We can type dv as dump variables or dv/i/v capitalized gives more info. So there was local variable pi. It is located in this at memory that is referenced by the value of RSP stack pointer plus offset. This is local variable, and you see PRV means you need full symbols for this. And if you go back to source code, this is our PI variable. You see it is expected to be 0, and so it is 0 indeed. And we can double check, disassemble this function. We see that this value is used and then is referenced, and 1 is moved to memory and points by null pointer. This pointed by null pointer. So all seems to be correct. So we can move down. After frame C there is frame D. So let's frame D, set frame D, and it has different, of course, local variables and parameters. See, they are all here. We can double check that from source code. That this local 3 should be equal 3, and this is indeed. And there are also parameters. However, you know that parameters are passed through registers. So let's move to another frame E. Mistake. And disassemble func2. So we see that when func3 is called, parameters, the first four parameters are passed in ECX, EDX, because they are 32-bit, and then pointers 64-bit are passed through R8 and R9, and this all corresponds to these four parameters. So they are passed through registers. And how come we see them as stack-based values? So for example, we go back. So how come we see them like this inside function 3? So let's go back to frame D and disassemble func3. We see that they are all saved onto stack, and so we see them when we type dump local variables command, because they were all saved on stack by compiler. Because I disabled optimization, so this may be the case. So this is all, you see, we compare with source code, external source code. So let's see how we can use source code in WinDbg. For this, we need to use another command, .crc path, and add the same folder. In that folder I put source code, so instead of sim path I put src, I use src path, or you can also use source file path dialog box. So you see something appeared in the background. So what we do, we use doc all, and now we have on the left we have command prompt and WinDbg output. On the right we have source code. So currently we are in function 3. Remember, we used to go to set frame D, and the return address points after function 4. So let's go down a bit. For example, set frame E. So you see we moved a bit up. So we are in function 2. You see that the code is highlighted, and we can move a bit further up. Frame F. You see we are in function 1, and you see the current location is also highlighted in function 1. You see also tooltips, also very useful. So let's try some commands. So we know some names like local_1. So let's use, for example, data to dump this local one. We specify L1. This is just one. So you see that it contains 1. So let's now try with param3, this should be a pointer. So with dp command param3 L1, so this indeed is a pointer, it contains some address, and so we can dereference it, for example, using either this, because we use C++ code, so I use, so you see that pointer points to 1, or we can use double dereferencing and use dpp command. So param4 should be some ASCII string, so we can, because it's a pointer, we use dp and the reference is as ASCII, so we put param4, so it's some string that contains f character. And let's now move a bit up and go to frame 10 hexadecimal after f. So you see the return value is highlighted in main. So let's check this local variable hello. For example, we can tooltip works fine, so let's use dpa hello L1, so points to ASCII string, or you can see it using dv/i/v capitalized to get all these local variables and their stack locations. Okay, there are some questions. What is the frame? Let's repeat it. The frame is just stack area that contains function parameters, return value, and local variable. So for example, here it contains return, address, and what parameters were passed, and also allocated local variables, if any. So this is all with this demonstration. So I do log close. And go back to presentation. So on this presentation I put some fragments, some command output, and also all these commands that I showed you. And finally, usual ban add slide. So accelerated Windows software trace analysis starts this week, and next accelerated Windows memory dump analysis will be in February next year, and some planned free webinars, I moved them to next year due to insufficient preparation time, but the first one, pattern-based software diagnostics, will be somewhere in January for sure. And so thank you for watching this episode. Please later check out the slides and recorded video from debugging.tv. The date of the next episode will be announced later, so most likely it will be next year, but I will see. So thank you very much for coming to this session. Thank you. Bye-bye.